This is Unit 7, Section 7.3. We're going to continue looking at the volume, and today we're going to look at pyramids and cones. So prior to this, we had practiced prisms and cylinders, and we grouped those together because there were two bases connected by a height. Today we're going to look at pyramids and cones together because they both have a height connected to one base to the apex. And so as we're looking at Unit 7, we're here where we're going to find the volume, and then we have one more section before we review and test. So diving right in, looking at the volume of a pyramid, we had looked at the relationship between a prism and a pyramid and saw that we had three of these pyramids that filled up the prism. And so that's why we still have the area of the base times height. So we still have capital B, area of the base, times height. Height is now from the center of the base, because we only have one base, up to the apex. So this will never be slanted. And so once we start looking at this, we did say, okay, we're still using the area of the base times the height, but a pyramid doesn't fill all of this volume. It's only 1/3 of what the prism would have been with the same area and the same height. So when we look at number 1, using this idea, we're going to find the volume of each pyramid and then round to the nearest tenth if necessary. So we need an area of the base and a height here. So my base here, I can see I have 4-sided objects, so I have a rectangle. So I'll do base times height here. And so in my calculator, I'm going to take 10 times 11. And I get 110. And my height, okay, so they're pointing at this length here. It's not slanted. It's from the apex to the center of my base is 16. So for volume, I can do 1/3 area of the base. There's my 110 and times the height, 16. So I'll pull this out of my calculator. So I'm going to do 1/3. And then I have 110 for the area of my base, times 16 for the height, apex to center. All right, so I don't want to answer leave my answer as a fraction like this. I want to round to the nearest tenth, so I'm going to use my toggle button here, and I get 586.66666. I'm going to use this 6 to bump this up to a 7, so 586.7, and I have inches cubed to fill up that figure. On number 2, okay, I'm looking for, again, an area of the base and a height. Area of the base, okay, I have a rectangular base again, so 21 times 9. All right, so in my calculator, let's find the area of the base. 21 times 9, I get 189. And the height here, again, it's going from apex to the center of that base. They're telling me it's 5, so I can go to my formula. 1/3 area of the base times height. And so in my calculator, I will do the 1/3, 189 times 5. And double check me, I get 315. I didn't need to do any rounding on that one. So 315, and this will be cubic yards. All right, make sure that you're answering those questions and writing these down. The next one we look at, okay, so again, looking for area of the base times the height. And then we'll do 1/3 of that. So area of the base, ooh, okay, 4-sided object again, 14 by 14. So grab our calculator, find the area of that base. We like when we have rectangles, they're quick. 196 here. And then our height, we go from apex to center. This is not given. We are missing that piece. So the 2 that we just did prior, we had it. We were ready to go straight to our formula. Now we need to find this height here. And so what they did give us is the slant height here. So that's slanted down the side. So if I draw this in, do you see how that makes our right triangle here? Okay, we have an unknown value here, but we have a known value here. And if you look across here, this piece will be the same as this piece as I'm drawing it in. And so if I know half of this side, I know this base of the triangle. So I have a triangle that looks like this, where it's 7, my unknown height, and 25 here. This is where Pythagorean theorem comes in, and I can do x squared plus 7 squared equals that 25 squared. All right, so once I solve this, I'm going to use my to squiggle apparently. I'm going to use my calculator to subtract 25 squared minus 7 squared to get x squared by itself. So I get 576 here, and square root to find the height there. So I'll take the square root. Whoop, that's the wrong button. Square root of my answer, and I get 24. All right, so it was close to the 25, but the height of this is going to be 24. Once I have these two pieces, then I can go to my volume formula. 1/3 area of the base times the height. So we had to do this to find the height here. In our calculator, we can now do our 1/3 and our area of the base. That square is 196, and we found our apex to center height, which is 24. So when I put that in my calculator, I get 1,568. No rounding necessary, and I have feet cubed. All right, on the next one, maybe we have everything here. Pythagorean theorem can help us if we don't. All right, so I have a base here. Okay, so this is no longer a rectangle like the previous three. We have a triangle. I only see 1, 2, 3 sides here. All right, so I'm going to do base times height of that triangle. They're telling me that's 12 and 7.5. And because it's a triangle, we divide by 2. All right, so I'm going to do base times height divided by 2. So I get a height, or an area of the base is 45. All right, the height, we didn't have to do Pythagorean theorem. They were already giving us apex, the center of that triangle is 10. So I can go to my area formula, 1/3 area of the base times height. And my calculator, I can go 1/3, because it's not a full prism, it's 1/3 of one. Area of the base times height. And that's where I get my 150. So this is going to be 150 little cubic millimeters that would fit inside of that object. So again, sometimes we're given all the pieces, but we need to make sure we're correctly identifying our base and using the height that's appropriate. All right, so on the next one, number 5. We are looking at finding the volume of our pyramid. We have an apex, okay? We have our height, that's good. So we're looking for area of the base times height. 1, 2, 3, so I see a triangular base. So I need a base times height divided by 2. Okay, so on here, what do we got? Base, we're missing this piece here because I have to go base times height. And this is not perpendicular to anything. I'm not given this piece like I was on the previous problem. So go back down. Let's do Pythagorean theorem. I do have a right triangle base, but I don't have the right angle here. I'm missing this piece. So I have my right triangle where I know this is 14. They're pointing at that. We know this is 22.1, but I'm missing this piece. So I'll set up x squared plus 14 squared equals 22.1 squared. And then I'll subtract to find that missing piece. So I'll go 22.1 squared minus 14 squared. And that's where I got 292.41. Ooh, okay. But I need to square root to get what x is, because I thought, wow, that's really long for that triangle. I wouldn't even make a triangle. So once I square root my answer here, and that's where I get 17.1. All right, so we needed that height so that we could go base times height of our triangle to find the area of this base here. So 14 times 17.1, all out of 2. So we get an area of that base of 119.7. And again, we had to use Pythagorean theorem to find the area. And the height now is 19. So once I have those two pieces, I can find the volume. 1/3 area of the base times height. So in my calculator, I'll be able to take this and I will go 1/3 area of the base, 119.7, times the height, which we had was 19 given to us. So now I get 758.1, so that was already rounded to the nearest tenth for us. And my units are meters cubed. And on our last one on this page, all right, area of the base and a height is what we're looking for here. Ooh, okay, so we have a triangular base, so I only see 3 sides. So I need base times height divided by 2. Okay, so we don't have any perpendicular. This triangle looks like this. They've given us 10, 10, and 10. But if I need to find the area of this base, I need to go base times height. So I'm missing this piece here. All right, so again, Pythagorean theorem wins the day here. So we're going to take this and we'll have x squared plus, okay, this piece, if we take that and divide it in half, now we have 5 squared, and that's going to equal our 10 squared. Back to my calculator, so I can go 10 squared minus 5 squared, and that's where I get 75 for x squared. Square root to get x by itself. So now I'll square root our 75 there, and I get 5 radical 3. All right, so I can leave that in the radicals. We've dealt with those before. So I can say 5 radical 3 here. If you give me a decimal there, that's okay too. We'll just be a little bit off on our volume. Because as soon as you round here and then you round here, we're going to get a little bit further away. So in my calculator, I'm going to take that answer times 10 divided by 2. And that's where I get 25 radical 3. All right, so now I found the area of the base. Whew. All right, so what about the height of our pyramid? Good, we didn't have to do anything to find it. They're already telling us apex to center is 16 is what they're pointing at. So our volume, we're going to take 1/3 for pyramid. And then we'll do 25 radical 3 times 16. Again, my calculator will do a lot of this for me, so that's why I'm letting it figure that out for me. So 1/3, 25 radical 3, and times 16 for the heights. So rounded to the nearest tenth, I get 230.9401. Okay, so rounded to the nearest tenth, that 4 is going to leave that 9 alone. So 230.9 centimeters for my units cubed. If you're missing a part, don't force it with one of the other numbers that's given. Use Pythagorean theorem. That's why we practice an entire unit on it. Use Pythagorean theorem to find that other missing piece. On the next part, we'll switch over just like we did with prisms to cylinders. We can also relate pyramids to cones. And so when we're looking at the volume of a cone, our base is going to be a circle. And so that's why we've substituted in the capital B with the area formula, because this is always going to be the same when it is a cone. It'll always be pi r squared because we know the base is a circle. So the two things that we need for the cone are the radius to square it and the height to multiply. So find the volume of each cone below and round to the nearest tenth. All right, so we need a radius and we need a height. Okay, this still has to go center of base to apex. So kind of keep that in mind that we're still never slanted. All right, so we have to go from center here. All right, so hey, right away we have our radius is 9 and center to apex, that's not slanted, there's 17. All right, so this is giving us exactly what we need, so we can put that in 1/3 pi r squared times height. And back to my calculator to find that approximation. 1/3, I got pi button, we got 9 squared, and 17. Looking good, looking good. So we have 459 pi. That would be the exact answer. Our calculator is going, are you sure you want to round this? Because this is not rounded. It's 459 pi exactly. Pi is irrational, so it's always going to go forever. So as soon as I hit my toggle button, this decimal ends on our calculator, but it actually keeps going forever. So my approximation here, 1,441.9. Ooh, and that 9 is going to bump this up to 0, 10, and bump that to 2. So this is going to be 1,442.0 because it's almost looking like a 19 and bumping that up to 20. What are my units here? Yards cubed. On number 2. All right, so to do a cone, we need a radius and a height. So the radius here, we get 2.5. Okay, notice I had to cut this 5 in half. They gave me the diameter here. The radius I have to divide by 2. The height, I'm going from center of base to apex, is 8. All right, I have my 2 requirements here, so I can go to my formula. 1/3 pi r squared times height. And plug and chug in my calculator. So I'm going to go 1/3 pi, don't forget that pi button, 2.5 squared, and times 8. All right. Okay, so because we already put 2.5 in there, our calculator knew that decimals were good. So here we're going to have 52.35987756. Our directions still say round to the nearest tenth, so the 5 will bump that to a 4. So I'll have 52.4. And that will be inches cubed. All right, last one on cones here. All right, again, for a cone, we need a radius and a height. Okay, so they gave us diameter. Let's divide that in half to see what the radius is. So I'll take 13.5 for the radius. 13.5 here, 13.5 here. The height, so tempting to use this 22.5. But this goes from apex to edge. We need apex to center. This is our height here. So to the side, I'm going to use Pythagorean Theorem to help myself out here. I have 13.5 squared plus that unknown height squared, and again, you can use x, equals the slanted height, 22.5 squared. This is the slant. We want to be careful on that. All right, so my calculator, I'm going to use it to help me find that missing height. So I'm going to do 22.5 squared minus 13.5 squared to get x squared by itself. In this case, I said h. And then square root to undo squaring. That's our inverse operation. So I'll square root my answer. And that came out nice. I have 18 is my height here. And I don't know why I was writing here. I meant to write it here. Once I have my radius and height, I can find the volume. 1/3, I forgot pi, 1/3 pi radius squared times height. You do not have to have these memorized, but you need to know how to use them. All right, in my calculator, I can simplify this, rounded to the nearest tenth. So 1/3, again, don't forget pi. I think that's going to be a common mistake. I've just done it. All right, we want to square our radius and multiply by the height. All right, so now we get a large number there, but we're also dealing with a height of 18 and a diameter of 27. This is really big. So we get 3,435.3. 3,435.3 is what I'm looking here. And my units are kilometers cubed. All right, so as we're looking at this one, we want to make sure that we are able to apply when we have a pyramid versus a cone, and making sure that we have those correct here. And so our last one is an application. And so on the application, it says, Caitlin must build a sandcastle in the form of a square pyramid. So they're telling us the base is a square. She bought 3 bags of sand containing 1,200 cubic inches of sand. Will she have enough sand to build this castle? Justify your work with answers. All right, so we need to find the volume to see how much is her 3 bags going to contain here. So I'm going to take the area of the base and the height to find the area of or the volume of our prism. We have a square, they already told me, pyramid. So I'll take 25 times 25. The height, center to apex. So we have our center, we have apex. The height is 18. So the volume for the sand castle that she's building, we're going to take 1/3 for pyramid, area of the base times the height. All right, so calculator, help me out here. We have 1/3. Area of the base, 625, and times the height of the pyramid, 18. So 3,750. All right, so this is how much sand she needs. She needs 3,750 inches cubed. Okay, she has 1,200 in each bag of sand. So, okay, let's think about this. So she has 3 bags here. And 1 bag is 1,200. So 3 bags, if I take 1,200 times 3, all right, she has 3,600 total here. All right, so will she have enough sand to build this castle? Is this enough? And so if we look at our value, we need 3,750. This is not enough. So she doesn't have enough sand. All right, so our main lessons today, we're looking at the pyramid formula, which is the same that we practiced last time. Be careful. Sometimes we need to use Pythagorean Theorem to find a missing part. Don't force it. Then we looked at cones and then an application here. Let me know if you have any questions, and I'm happy to help.